Let's start off with questions from yesterday's assignment. Any questions on the assignment from yesterday? No? Okay. Number 18. Number 18. Describe the end behavior of the function 7x to the 7th plus the rest of it. Because it's 7x to the 7th plus 12x to the 5th minus 6x to the 3rd minus 2x minus 18. Now, the reason I didn't write the rest of it out is because for end behavior, we need the degree, and really we need the leading coefficient. And if we look at this here, the degree is odd, and the leading coefficient is positive. Now, we would look back at the chart because we had only 4 examples that we could have. And since it's odd, it means it's going to end up going in opposite directions. And positive is going to tell me that f of x approaches infinity as x approaches infinity. And it also means that f of x is going to approach negative infinity as and that would be it. For the most part, when I think about this here, I think about the cubic function, or x cubed, because the basic graph of x cubed, I'll do this in 2 different colors, is this function here. As x approaches positive infinity, it's increasing. And as x approaches negative infinity, the function is decreasing. And I think about this one here. Now, if we had, it'd be negative because this is odd and positive. It would just be the flip. Doing this here, which would just switch it from f of x going instead of positive infinity positive, it'd be negative. So essentially these two here would switch. And that'd be the only real difference. Any questions on this here? Any other questions on any of these here? All right. Let's go on and look at today's chapter. So if we look at this here, let's take them out, thank you. We're going to be dealing with addition, subtraction, and multiplication. We're not going to deal with division today. We will be dealing with division tomorrow and Thursday. Now, when we add or subtract, here we'll focus on adding first. 2 polynomial functions, we can either add them vertically or horizontally. And when we add them vertically, we're just putting them over the top of each other. So to add these 2 vertically, we'll all just start off with the first polynomial expression and rewrite it out. So 3x cubed plus 2x squared minus x minus 7. So I'm just going to write it out. And then I'm going to write the other one underneath it, matching up any like terms. So we do have an x cubed, so I'll put it under 3x cubed. Minus 10x squared, we'll put it under the x squared. Do we have an x term here? No. So we could put plus 0x, and then we can have plus 8. Because in the first hour, I just left it blank, because we can either leave it blank or put 0x to take its place. But we just need to make sure that we have all the like terms lined up. And now what we're going to do is we're going to add. Well, 3x cubed plus x cubed is x cubed. 2x squared plus negative 10x squared is negative 8x squared. Well, negative x plus 0x is negative x. And negative 7 plus 8 is 1. That's it. That's all we have to do for this here. And we'll do those in a minute. But any other questions on this first one here? All right. Let's look at horizontal. So looking at horizontally, straight across. And we've done addition and subtraction horizontally before. So really, when we do this horizontally, we'll rewrite them with parentheses. And we're adding to it negative 5y squared plus y minus 4. So we're adding it horizontally instead of vertically. Now this here, because we're adding, we are going to drop the parentheses because this here is not really going to change. The addition sign won't change anything in the second set of parentheses. So we can just drop them. So really we just have 9y cubed plus 3y squared minus 2y plus 1 plus negative 5y squared, or we can just write minus 5y squared plus y minus 4. Now we could go on and combine like terms at this point if we want to, or we could rewrite it with the like terms next to each other. And if we rewrite it with the like terms next to each other, we're just to say 9y cubed plus 3y squared, well, minus 5y squared minus 2y plus y plus 1 minus 4. I just rearranged it so that the like terms are next to each other. And then we're just going to combine them. And when we combine the like terms, well, 9y cubed will be by itself because there's no other like terms with it. Our 3y squared minus 5y squared would combine to become negative 2y squared. Our negative 2y plus y is going to be negative y. And 1 minus 4 is negative 3. And that's it. Now this middle step here where we've moved the terms around is not necessarily necessary because really we're combining like terms. So if you can see that without putting them next to each other, that's perfectly fine. Any questions with addition? Do we feel comfortable with adding and subtracting these polynomial functions? Do we need to see another example of one of these here? No? One more? Are we good? Okay. Because that's all we're doing is we're really just combining the like terms either with addition or subtraction. With addition, it's not too bad. We're just adding the like terms together and we're good. The ones that we do need to be careful with are our subtraction. Because when we subtract something, it is changing the signs of the second set of terms because we're subtracting it from the first. Now, when we do this vertically, well, we can go on and do it exactly as we did the first one. Is rewrite out the first set of terms on top. And then we'll rewrite the second expression on bottom. So the first thing we're doing is just rewriting it back out. Now this time, instead of adding, we are subtracting. I go on and put a subtraction sign not just at the front, but under each set of terms, just as a reminder for what we're doing. Because some of the times when we get some of these here that are 4 terms long or longer, and we get in the midst of doing the combinations, we'll start adding by accident instead of subtracting. because we're too focused on the numbers and not on the actual operations. So it's sometimes good to put this subtraction across all the way through. Now, we can go on and just subtract, because we can say 2x cubed minus 8x cubed, which would be negative 6x cubed. Now, another handy thing is like this next one here, because we have 6x squared minus negative 3x squared. Well, the negative and negative make a positive, so right here I can go on and rewrite it as plus 6x squared plus 3x squared is plus 9x squared. So it's a nice little reminder as we're doing this. We can move on to the next one, negative x minus negative 2x. Well, the negative and negative would make a positive, so negative x plus 2x is plus x. And lastly, 1 minus 9 is negative 8. And that's our answer. Now, unfortunately, we can't do these in the calculator because, again, like we talked yesterday, x has to have a value. For these here, the TI 84 plus and the 84 plus CE, they really need a value for x. The TI 89s will be able to do these, but they're banned from most all standardized tests except for the SAT. I don't know about the full one, but the pre-SAT did allow those. But any questions on subtracting these vertically? Well, let's look at subtracting horizontally. And horizontal, when we subtract horizontally, it will be almost the exact same as subtracting or adding horizontally. Because we'll start off by just rewriting it. Our first expression minus the second expression. Give you all a second to write that down. Now with this one here, with subtraction, we do have to be careful because we're changing the sign of everything in the second set of parentheses because of that negative. Now the first parentheses will stay the same. We'll still have 3z squared plus z minus 4. Now in the second one, we're going to have negative 2z squared minus 3z because that negative is being applied to everything inside the second set of parentheses. And this is where most errors occur. Because I've seen a lot of times that they will, or most students will apply the negative to the first term, but then leave everything else the same. But we have to apply it to every single term. And now we can go on and combine our like terms. Well, two of our like terms are 3z squared and negative 2z squared. Well, would be z squared. We have z and negative 3z, which would be. Now, do we have any like terms with negative 4? No, so it just stays negative 4. And that's it. Any questions on any of this here? Do we feel comfortable with addition, subtraction horizontally and vertically? Really, with especially subtraction, doing these vertically is almost a little bit easier because we're not having to worry about changing the sign or that sign flip because we're subtracting. It's already taken care of. And it's a little bit easier to kind of organize it this way. We just line it up, add or subtract like terms, and move on. Do we need to see another example with addition or subtraction? Okay. The last thing we're looking at today is multiplication. Now we can multiply vertically. I'm not a big component of multiplying vertically. It's a little funky. I think it's funky. You might not. And that's perfectly fine. Now we'll go on and look at an example of this. different color. Okay, whatever. Try it one more time. Won't work. Okay. And what we're doing is we are multiplying these two together. And when we multiply these two together, it's almost going to work exactly like if we were multiplying two numbers together, saying 24 times 12, and we did this vertically. It's going to work the exact same. But we'll have addition and subtraction in the middle. Because if we multiplied two things together, well, we would do negative 3 times 4, which would be negative 12. Then we would do negative 3 times 2x, which is negative 6x. And lastly, negative 3 times x squared is 3x squared. So it's almost the same as what we did for 24 times 12, because if we did this over here, because it'd be 2 times 4, which is 8. 2 times 2 is 4. The only difference is that we have addition, subtraction between each of the signs, terms. Now, for this here, 24 times 12, well, what would I do next? We would put a 0 before we start multiplying by the tens, because then we would do 1 times 4 is 4, and 1 times 2 is 2. And then we would add and get 288. So here, what do we think the next part's going to be? Because we're going to put a 0 for the x. Because we're going to do x times 4, which is 4x. Now, since it's positive, we will put a plus. X times 2x is 2x squared. And since it is positive, we'll go on and put a plus, because I do know that there's another term after it, because we still have one more multiplication to do. X times negative x squared is negative x cubed. And last but not least, we're going to add all of our like terms together. Now, for this here, with normal addition, especially with our numbers when we multiply, we always start from the right and go to the left, because here we would do 8 plus 0 first, and then 4 plus 4, and then 2, because if we have a remainder, or if it goes over 10, it has to bump 1 over. Here, it really doesn't matter, because no matter how I combine any of these two terms, it's not going to magically move over to the next one, because I'm not going to be able to add x and magically get x squared. That only works with multiplication. So if we add these together, well, negative 12 plus 0 is negative 12. Negative 6x plus 4x is negative 2x. 3x squared plus 2x squared is squared. And then we have negative x cubed. And that's our answer. Any questions on this here? What do we think for this here vertically? Not too bad. Let's do it horizontally. And doing this horizontally is actually going to be familiar for what you've already done before. Because when we multiply these horizontally, really what we're saying is that I'm taking y plus 5 here and multiplying it by 3y squared minus 2y plus 2. So we're going to be distributing. We're going to use the distributive property. Well, the first thing I'm going to do is I'm going to multiply through by y. Y times 3y squared is 3y cubed. Y times negative 2y is negative 2y squared. And y times 2 is plus 2y. So we just distribute the y. We multiplied each of the terms in the second set of parentheses by y. And what do we do next? We multiply each of the terms by 5. Well, 5 times 3y squared is plus 15y squared. 5 times negative 2y is negative 10y, and 5 times 2 is plus 10. Any questions on any of these? Well, not quite finished yet. We still have to combine our like term. Now, 3y cubed doesn't have any like terms with it. But negative 2y squared and 15y squared are like terms, and we can combine those, which would be plus 13y squared. Then we do have 2y and negative 10y, which is negative 8y. And lastly, we have plus 10. Y'all feel pretty familiar with horizontal? Because it's just our distributive property. And that's it. Pick which way you like better. For any of these here, horizontal or vertical. Pick which one you like better and do it. Because no matter which way we pick, we will still get to the same answer. You'll still be able to get to the same answer. Any questions on any of this here? Do we need to see another example of multiplication? Yes. You can. I'm not going to be nitpicky about it either way. Because most things where, like last chapter, we're dealing with completing the square or using the quadratic formula, one of those, it's good to know both. Here, it really doesn't matter. So I'm not going to be nitpicky of which way you do as long as you are able to get to the right answer. So I'm not going to be specific, and I don't believe the test or review. I'm just going to ask you to add, subtract, or multiply. Does that make sense? Now with division, I will specify one way or the other, because there's going to be some cases where we'll cover long division tomorrow, which will work better with long division, and then we have synthetic division. There'll be ones that work better with synthetic. And as much as y'all like it, or much as you'll end up finding out you'll prefer synthetic division better than long division. But do we feel comfortable with this multiplication? Okay. Let's go to the next one. Well, multiplying 3 binomials. Let's look at this one here. It's not any more complicated or any more challenging than the one we just did, except that we have, well, three things that are being multiplied together. That's the only real difference. And when we're multiplying 3 things together, really, all we got to do first is just pick 2 to multiply together and go from there. And it really doesn't matter which 2. So I could multiply these 2 together first. Or I could multiply these 2 together first. Or if I wanted to be a little bit weird, I could multiply this one and this one together first. I really wouldn't stick with the ends because that makes it a little bit challenging jumping around the middle one. But it really doesn't matter which 2 we multiply together first. I'm just going to multiply the first 2 since they're the first 2. And we'll do exactly what we just did. So we'll do x times x, which is x squared. Then we can do x times 4, which is plus 4x. Then we'll do the exact same thing with negative 1. Negative 1 times x would be negative x, and negative 1 times 4 would be negative 4. And we get this here. Now what would we do next? I would do one thing first. Do we have like terms? Might as well go on and combine these like terms before we multiply again. There's nothing wrong with doing the multiplication. It's just that we would have 2, 4, 6, 8 terms compared to 6. So it's a little bit easier to work with. So if we combine our like terms, our 4x minus x would be plus 3x minus 4. And it's not so much here, but the bigger these get and the more that we get term-wise, it's easier to keep these as simplified as possible. Because the less terms that we have to work with, the better. Because the more terms that we get, the easier it is to make little mistakes here and there with just multiplication, and it's harder to find when we start looking at, say, 12 terms. So whenever we can simplify down and condense down, we need to. It's going to make it work a little bit better. Now lastly, we'll go on and do our last distributive. X squared times x would be x cubed. X squared times 5 is plus 5x squared. Then we'll do the same thing with 3x. 3x times x is plus 3x squared. 3x times 5 is plus 15x. And lastly, with negative 4 times x is negative 4x. And negative 4 times 5 is negative 20. Anybody notice something that worked out kind of interestingly enough? Where are the like terms? Right next to each other. So that kind of worked out nicely. So we'd have x cubed. 5x squared plus 3x squared is plus 8x squared. 15x minus 4x is 11x minus 1. And we get this here. Any questions with multiplying binomials, 3 binomials? Or really any questions with multiplication in general? No, it's just working it out one step at a time. Now, some of you noticed this here already. This here is just really some shortcuts for multiplying these out. And one of the first ones is the sum and difference of perfect squares. As we talked about factoring the difference of perfect squares, sum and difference. So it's the difference of perfect squares, really not sum and difference. Because a squared minus b squared, when we factored it, it went to a plus b times a minus b. If I know that the two terms are the exact same being multiplied together, really it's just going to be the first term squared minus the second term squared. But if I multiplied it out, I would get to the exact same thing. It wouldn't make a difference. It's just making this a little bit shorter. The same is true for these here, a plus b squared. Whenever I have this set of parentheses squared, it works out to be the first term squared, if it's positive, plus 2 times the 2 multiplied together, plus the second term squared. Same thing is true with subtraction, but the middle term is negative. And kind of the pattern for cubes. And it works out that someone, I'm going to skip this here for a second, Pascal actually came up with this triangle that's based off of kind of the leading terms of how this will work out for every single time. To where if I picked one, and I'll pick one where a and b are both 1, so let's say x plus 1 to the 5th, because x and 1, they both have number of 1. This here is actually the numbers that correspond to it. And x is always going to start, so the first term is always going to start with the power that we have. So x to the 5th, and the number in front of it is 1. Plus, we decrease this power by 1 and multiply it by b, which is just 1. And what's our number in front? 5. Plus, the next number in line is 10, yes? X would decrease by 1, and we would multiply it by b, and then we would have the same thing with square. this here is a setup and way to multiply these, if we're having to multiply lots of them together, a lot faster. Because otherwise, if I wanted to find this, well, we would have to do x plus 1 times x plus 1 times x plus 1 times x plus 1. We'd have to multiply it out 5 times. So this is what Pascal's triangle is nice, is that it simplifies a lot of this, especially for multiplying by the same term more than once. If we're multiplying by different terms, this doesn't work. It only works if it's the same term to a power. Does that make sense? So this triangle here wouldn't work if we're talking about 2x minus 7 times 2x plus 4. And doing that over and over again. We'd have to do each one individually. Because if we had this here, Pascal's triangle would work for each individual one. It wouldn't work for the whole set. Now, we'll do the first two here. And working these out. Is we could use the pattern, because the first one, 4n plus 5, 4n minus 5. Their difference are really, we're looking at a squared minus b squared. Well, a would be 4n, and what is 4n squared? 4 squared is 16, n squared, and 5 squared would be 25. So really we're looking at 16n squared minus 25. Let's go on and do the multiplication out and see what happens. Well, 4n times 4n is 16n squared, which we got, yes? Now the next one would be 4n times negative 5, which is negative 20n. Then we would have 5 times 4n, which is plus 20n, and 5 times negative 5 is negative 25. While doing this here, we ended up with a few more terms, yes? Do we have any like terms? Well, negative 20n plus 20n, yes? Which is 0. These are gone, leaving me with 16n squared minus. So we got the exact same thing, it just was a few more steps. Because if we remember that pattern with the difference of perfect squares, we can get to this here a little bit quicker. Bless you. Now the middle one, with it being multiplied by itself, now for b, the kind of shortcut to it is really it's saying the first term squared plus, well here it would be minus 2 times the two terms multiplied together plus the last term squared. Well, the first term squared would be 81 y squared, because 9 times 9 is going to be 81. Y times y is y squared. Minus kind of the 2 times the two terms multiplied together. Well, 2 times 9 is 18. Times 2 is 36. Plus the last term squared. Well, 2 squared is 4. Would be the polynomial. Now let's go on and actually work this out, multiply it out. Because really we're saying 9y minus 2 times 9y minus 2 is multiplying by itself. Well, 9y times 9y would be 81y squared. 9y times negative 2 is negative 18y. Negative 2 times 9y is negative 18y. And negative 2 times negative 2 is plus 4. And when we combine our like terms, do we end up back at the same thing? Yeah. So if the shortcuts make sense and they click in your head, use them. If not, multiplying them out will get you to the exact same place. Any questions on any of this here? We good with all this here? All right. Well, that is it.